Today's topic is dilution. Dilution is a process to lower the concentration of a solution by adding solvent. We're going to practice a few calculations related to the dilution process. Here is the key to understand what's going on in dilution. If the dilution is achieved by adding solvent, usually is water, we will know that adding water will not change the amount of the solute before and after the dilution. So dilution with water, solvent only, does not alter the number of moles of solute present. And very likely, this is the equation you're going to use to set up your calculation. The moles of solute before dilution equals the moles of solute after the dilution. Well, it doesn't have to be moles. As a matter of fact, this is the general concept of dilution. The amount of solute before dilution equals the amount of solute after dilution. Doesn't matter if you're talking about moles or mass. All right, so let's look at how we're going to apply this concept in real-world calculation. This is the formula provided in the book for us to use when we do dilution calculations. Subscript S represents information about the stock solution, the more concentrated solution. Subscript D represents information about dilute solution. Capital letter C represents the concentration. Capital letter V, well, this is the confusing part. When we see capital letter V, very likely we will say, oh, that's the volume. Well, it could be the volume, but it doesn't have to be. Whether it's volume or something else is decided by what kind of concentration you're talking about. If C is molarity, if the concentration is expressed in molarity, then V is volume. If C is percent by mass, if C is percent by mass, then V must be the mass of solution. So a better way to put this is this. The concentration of the stock solution multiplied the amount of the stock solution, it could be volume, could be mass, equals the concentration of the diluted solution multiplied by the amount of the diluted solution. Again, it could be the mass, could be volume, depending on the concentration. So let's dig a little further into this formula. Let's say molarity. What's going on? Molarity, if we use capital M to represent the concentration molarity now, the formula becomes molarity of the stock solution times by the volume of stock solution equals the molarity of the diluted solution multiplied by the volume of the diluted solution. What is that? Why is it equal? So remember the definition of molarity. Molarity equals moles of solute divided by liter volume of solution. Volume in liters. So moles of solute divided by volume equals molarity. For this equation, if we multiply both sides by V on the left, it is molarity times volume equals, on the right, will be the moles of solute. So M, molarity multiplied by V, the volume of solution, gives us the moles of solute in the solution. Therefore, look at this equation. On the left, is the moles of solute in the stock solution. On the right is the moles of solute in the diluted solution. We have clarified on the last slide that the moles of solute will not change before and after the dilution. Therefore, they equal. Makes sense. What about percent concentration then? Percent concentration, remember, percent by mass concentration, mass over mass percent concentration equals the mass of solute divided by the mass of solution. This is the definition of percent by mass. Again, to both sides of this equation, let's multiply both sides by the mass of solution. On the left, it is percent by mass multiplied by the mass of solution. On the right is the mass of solute. Multiplied by mass of solution, they will be cancelled. So the mass of solute is left here. All right, guys, follow me? So what I am trying to say is that when you use the percent by mass concentration multiplied by the mass of solution, you're going to get the mass of solute in the solution. Again, mass of solute before and after the dilution will be the same. So when you multiply the percent by mass of the stock solution by the mass of the stock solution equals the percent by mass of the diluted solution multiplied by the mass of solution diluted. What I'm trying to say is that the V here in the original formula may be volume in the case of molarity, may be mass in the case of percent by mass. It's all dependent on what kinds of concentration you're using. I hope I made that clear to you, so let's move on. Concept check. There's a 0.5 m solution of sodium chloride sits on the lab bench. Which of the following will decrease the concentration of the salt solution? Decrease the concentration. Add water to the solution. Well, that's dilution, so that will decrease. First of all, that will be our answer, at least one of these right now. Adding solvent will decrease the concentration of our solution. That's dilution. All right. Pour some of the solution down the sink, while pouring the solution out will not change the concentration. It will change the amount of the solution, but the concentration will not change. That's not an answer. Add more sodium chloride. If you add more solute to the solution will become more concentrated. That is not going to work. Let the solution sit out in the open air for a couple of days. When the solution sits in the open air, water will be evaporated. So basically, the amount of solvent will be reduced. As a result, the concentration will increase. That is not the answer. So A is our choice. Exercise. What is the minimum volume of a 2.00 molarity sodium hydroxide solution needed to make a 150 ml of 0.800 molarity sodium hydroxide? All right. looks like there is an original stock solution. Concentration is given molarity. So molarity of stock solution is given. Molarity of diluted solution is given. Volume of diluted solution is given. It is asking what is the volume of the stock solution needed. So Vs is what is wanted. Well, we use what we just learned. The amount of the solute before and after the dilution will not change. So Ms, that's the concentration in molarity, multiplied by Vs, that's the volume of the stock solution needed, equals Md, that's the molarity, the concentration in molarity of the stock solution, multiplied by Vd, that's the volume of the dilute solution. When you use this, the V could be in milliliter, could be in liter, as long as the two Vs and Vd are in the same unit. They don't have to be in liter only. It could be in any volume unit as long as the two are in the same unit. So we're going to use milliliter directly. We do not need to convert it to a liter. Okay. Now, we will divide both sides by ms so that we can isolate the Vs out. So now it becomes Vs equals Md times Vd divided by Ms. Put the numbers in. Md, diluted molarity, 0.800 times Vd, 150.0 ml, keep in mind, divided by the molarity of stock solution, 2.00, equals 60 point. Is it 60? Yeah, 60.0 milliliter. That's it for today.